Hi, I'm Kevin Su. I'm software engineer at Union.ai in Austin, mainly working on the Flyte project. And Evan is a senior software engineer from HBO. Today, we are so excited to share about the Databricks plugin integration. So today agenda, I'm going to give an overview about the Databricks plugin and the architecture behind it. And I'm going to give a quick demo. Lastly, Evan will share some use case and stories in HBO. So what is Flyte-Databricks plugin? Basically, it helps you schedule, monitor, and orchestrate Databricks job. So Databricks job is just like Spark job, but running on Databricks cluster. And Databricks help you create a new Spark cluster when job is running. And before using Databricks plugin, you have to go to Databricks console to manually click the button one by one to create a new job, or you have write a bunch of script to help you schedule or monitor your Databricks job. So we want to make running Spark on Databricks platform easy. So we create this plugin. It will help you submit a job to the Databricks and then monitor your job lifecycle. So this is that Databricks Jobs API. So it's pretty similar to Spark job, but we add a new config called Databricks config. And here you can see we define a Spark config inside Databricks config for your Spark job, and the tax name and the cluster spec. Databricks will help you create a new cluster for you, and you can also submit your Spark job to existing cluster. You just pass the cluster ID, and you can see the task. You just write the regular Spark code in the task, and then you can get the Spark session from the Flyte contacts, and then you use this Spark session to create your Spark job. So you can run this task locally, and you can also register this task, and Flyte will help you submit a job to the database, and then you can run this task on large scale cluster. I'm going to give a quick demo. Let me share my screen.
Do you guys see my terminal?
Yes.
Yep.
Okay, awesome. So this is my Spark workflow. So you can see the T1 tags is just a dummy tags, which return a number of partitions. And then Databricks config define your cluster spec here. And then you pass the task config to your Spark job. And here we just calculate the value of the pi, and you write your regular Spark code in your Spark job here, and pretty much like it. And then I'm going to run it locally. And when you run the job locally, instead of creating a new cluster, PySpark will run your code in JVM, Java Virtual Machine, and then it will send the result back to the Python process. And then, yeah, it's running. Yeah, it worked. And then you can also just register your Spark workflow. I already registered it here. Here, yeah. You can see my console. Okay, awesome. So this is my Spark task, Spark workflow. And then you can relaunch it. And then let me go back to previous drivers. So when you go to the Spark tasks, there's a link. You can link to your Databricks console. When the job is complete, you can see all the task log in this console, and then you can see your cluster spec, cluster config, and then the command you run. And you can go to the Spark UI to see the detail of the Spark task. You can see the event timeline on this console, and then you can see the Spark config you have, and then you can see the number of executor you run and how many tasks fail, how many tasks succeed. Yeah, and then go back to the Flyte console. Let's see. The Spark task is running, and then you can go here, go to the workflow, job run. You can see I just create a Databricks job, and the cluster is being created. After creating, Databricks will submit the Spark job to this cluster and run your Spark task on this cluster. Yeah, pretty much. And yeah, Tyler, could we go back to the slide? Yeah, so if you want to try it out, you can follow this documentation, and you can create a local sandbox and to run this Databricks job. If you want to run this code locally, just pip install Flyte plugin Spark. Next slide. Yeah, so the architecture behind that is, so just like regular Flyte workflow, you write a Python script for your workflow, and you build a Docker image for your workflow. You register this workflow to Flyte-admin, and when you run it, instead of like creating a pod on Kubernetes cluster, Propeller will send a REST request to your Databricks platform. And Databricks platform, what it does is that it helps you spin out a new cluster, and then you can also like enable the auto scaling. Like Databricks will help you like scale up or scale down your worker nodes. And in the driver node, like we run the Flyte execute. So what Flyte execute does is that it helps you download the previous text, the output, as download the text input from your S3 bucket, or you can also download the code from your bucket if you use fast register. So entire workflow is pretty straightforward. Like, next slide, please. So what's the benefit of Databricks plugin? So it's very easy to integrate with other service. Like you can imagine like you have a workflow, like select the columns or rows from BigQuery, and Flyte will help you convert it to the structured data set, and then you can just pass to the Databricks job. So although you're running Spark on Databricks, you can easily to access the data from like external data system, data warehouse, like BigQuery, Snowflake. And then after the job is complete, Flyte will help you serialize your Spark data frame again to the structured data set, and then you can pass your training job, distributed training, TensorFlow, PyTorch, etc. And then so you already integrate with like Spark. We already have like Spark transformer, so you can easily to like play around with your like structured data set. And another important feature is like local testing, which allow you to more quickly to iterate your Spark workflow locally. And auto scaling is one of the feature in Databricks, which help you run your job more cost efficiently. Yeah, next slide, please. So the future work, like we want to support the Databricks pipeline, which means like we can combine the Flyte workflow and the Databricks pipeline together, maybe use Databricks pipeline as sub workflow. So we can run both of them together in the same time. And then another is we want to support the structured data set, encoder and decoder for Delta Lake, which allow you to easily to access the data from Delta Lake. And yeah, contributions are welcome. Next slide. Yeah, Evan, you want to take over?
All right. Yeah. So yeah, what we're doing is we're just making movie and TV recommendations, and this involves aggregating streams of, people watching shows and folks clicking on stuff, and this turns out to be a ton of data. And so most of our pipelines are a mix of Spark jobs and then just normal Python tasks where you might have a big instance and train a model. So nothing too exciting, but there are these two architectures that we really need to have in our pipelines. And what we've seen is like when you have these two different architectures, like we end up with internal tooling that might be very overfit to running Spark, very limited, which doesn't have the flexibility that Flyte gives us. And then on the other end with Databricks, which is what we use for our data warehouse, it's really like UI based, which is great until you want to, deploy production ML models and you want to follow more of a code first approach. And so, yeah, we're in this case where we want to use Databricks and we want to use Flyte together. So that's where we're at. All right, next slide. So Databricks and Flyte, I think work really well together. Databricks has like an optimized version of Spark, which allegedly can scale for certain tasks. It also has a data warehouse, so they're really trying to handle the ML use case and the data warehouse use case. So they have like a query pane, and so we have a lot of different teams working out of the Databricks UI. When it comes to Flyte, what I mentioned, it has this code first approach. Kevin touched on all the things that we love, like with local testing. There's also typing. So it really provides this like sort of like software engineering workflow despite having different backend architectures. And yeah, I guess the final piece is like, I really don't like having to write code to package, code, all this stuff that isn't the actual machine learning and isn't the actual ETL, all of sort of the piping. And yeah, Flyte really gives us that for free, which is something that I really don't take for granted when I use Flyte. On the right, we have an example here of like a pre-processing job. This will run on Databricks, which is with just the different like PyFlyte commands. You can see here that like I was using an existing cluster, and once your cluster is spun up, it can actually accept multiple requests. It'll auto scale and it's set up. So, my tasks, even though they were split up, ran really fast because it didn't have to spin up some Spark clusters. So yeah, that's it. Next slide. Testing, just as an example here, Flyte makes unit testing straightforward, basically just bootstrapping off of the Spark plugin. And so this is just really useful for us because we have a few functions that will, process viewership data or catalog data, and now we can unit test them and reuse them. Something else is once we have the Flyte tasks, if we're iterating in a notebook, we can import the tasks from our Python module, and it's, then as part of like the data science workflow where we're investigating and iterating, we're able to just use these functions like normal Python on sample data, or if we have access to the Databricks cluster locally, then you can just pull data. So it's a really smooth dev workflow. Cool. Next slide. This is the final piece that we've been looking into is a lot of times, I've seen like the ETL or Databricks code being very separate from the Python code, or there's a lot of limitations where it's like, okay, we're going to set this up so you write a notebook, and then our tool will then package up that notebook and send it to Databricks. And so there's just like a lot less flexibility to have the repo structure that you really want. And so we've been experimenting with like, what does it look like if you really couple the code together for our projects? And, we're able to use relative imports for utilities because fast registration automatically, figures out what your Python module is by doing like a nice little search. And then we can write end-to-end tests of our workflows, which is something that's very hard to do with Airflow or other systems for orchestration. And I think it's like really powerful if you have an end-to-end workflow and you pass in a data set and it runs locally, like it's usually going to run in the cloud, especially the way the Flyte sets it up. So I really think it means we have a lot less like babysitting to do of pipelines, and we can just focus more on what matters, which is writing our machine learning code and making our models better. Cool.
Awesome. The integration looks pretty cool. Thanks, Kevin and Evan, for presenting the integration. Questions or feedback, anybody?
Yeah, I had a question. Well, thank you, Evan, for joining. I think I should introduce myself briefly. David Espejo here. I joined Union.ai last week to serve this community as an open source developer advocate. So I'm glad to be here. Yeah, you mentioned that one of the things that you liked about Flyte has to do with typing, because you mean the strong typing on Flyte tasks, right?
Yeah.
What exactly is what you like the most about that feature?
Yeah, great question. I mean, what I like is, a lot of the mistakes in defining the pipelines that I've run into, it's passing the wrong thing between tasks. And then the other piece is like being able to pass like structured data sets or data frames, just because like if you write it with those tasks, everything's happening behind the scenes to like load and move data around, save things. And like, I really found that a lot of the pipelining code I wrote was like taking a string path, passing it into I don't know, something that'll let me load it up from S3. And so all of those like little, all those commands end up, they're like surface area for things to go wrong. And so, yeah, having that all checked, it like has reduced the number of bugs that I see when I write my pipelines.
Awesome, thank you.
Can I add something to it? I think, by the way, my name is Ketan. I work at Union, but mostly serving the community. So one of the things that Evan just added, I just wanted to throw a little bit more color on that. Like, I think the boilerplate is essentially what Evan is referring to. Like when you're writing code, right, you're as a data scientist or a machine learning engineer, I don't want to think about writing data to S3. I don't want to think about converting data frames from Spark to Polaris, because I find Polaris useful in some cases when I'm working locally, or to NumPy or Pandas. And that, when we first started building, right, that was the most irksome thing that we wanted to get rid of. And that's why it's been encoded through the system. And what we, as a community, now that we've been working with the community for a while, I've seen that many teams have seen huge reductions in code bases. And what that really means is actually reduction in the code surface area, as Evan said, which is reduction in bugs and reduction in effort and deduplication, right, across this vast majority of a community. So I would highly encourage the community to contribute more towards type transformers and helping us build out like the library of connections and like what Kevin mentioned in his talk itself, like, you know, we want to integrate with Delta Lake. So that the data scientists and ML engineers never have to think about how does this data come from Delta Lake, or where am I going to put it, right? And I remember in one of my earlier first presentations when we were building Flyte was, and the reason we did it this way is because the data scientists used to store models in a specific path in S3, and the path was something like name of the data scientist / date of the run / time, blah, and model name. And if you rerun it on the same day or something, it overwrites and causes corruptions. And then who was remembering all of this? Some person in their brain was remembering all of this, and we just wanted to get rid of all of that. And so that's how the genesis of this auto management of the data happened. And I think we're still early in this stage, and we can do more. One question I had for Kevin and Evan is that you have been using Spark locally with this new integration. Do you find that useful? And how easy, I don't think you showed that, Kevin, but how easy is it to move from local to Spark on Kubernetes to Spark on Databricks, which is typically now a choice, which what I hate about most of these services is essentially there's no choice. Like I want my most important critical workloads to run in Databricks, for example, but I have some extra workloads that I want to run in Kubernetes. So is that really seamless, and is that just a slight change in config? Any comments on that, Kevin or Evan?
I can say first. So basically, if you run either like Spark on Kubernetes or Spark on Databricks, so first you have to set out some cluster or platform config in Propeller, but you only need to set it one time, like access token or your Databricks project ID, instant ID. That's it. And then, so what you have to do, like you just like specify your Spark config, and then so if you want to run on Databricks, you define the cluster config as well, like for your cluster for your compute instance. And it's very, I think it's very like seamlessly to move to the production cluster. You just register it and then run it. Flyte will help you handle like everything, how to communicate with like Spark operator, how to talk to like Databricks platform is very like easy and straightforward. And then you don't need to, from the user perspective, like they don't need to know how to use Databricks. So they just focus on their Spark code, right? So I think, yeah.
So if I had to paraphrase that, you're saying that basically no code changes. The same code runs locally on Kubernetes, Spark, or on Databricks, and you make the choice purely by switching configs. Yes, you have to enable some backend plugin is what I get, but which is, yes, you have to enable, but that's at the platform level. So the platform team can make a decision, and you can almost switch over to Databricks or from Databricks to Kubernetes overnight, right?
Yeah. And that was a big this plugin, like one thing when you work with Databricks is there's some like level of vendor lock-in. And so us knowing that, like, you know, we're running code on Databricks for what we want it to, which is its compute engine and its infrastructure. But, you know, if we, for some reason, our company decides to stop using Databricks because it's, you know, for pricing or for other reasons, like we have an alternative that's built directly into Flyte. And so that, yeah, that's just like a really nice feature for us. Because these things do change. Like people do switch from Snowflake to Databricks, and back and forth, and it's not necessarily the developers who have who make the choice.
Yeah, okay. No, that's great. I think even if we are not suggesting people leave Databricks. What we are trying to say is that there is a choice, and you can make the choice which is right for the project, for the product, for the business at that point in time. Yeah.
Okay, Evan. To that, a quick question.
Thanks.
Yeah, thanks for sharing your use cases. I'm curious how you mentioned, you kind of hinted at this, but I'm curious how the data scientists you work with, and maybe yourself, like how you've changed working with notebooks and working with Databricks. How has this Flyte integration sort of changed the mindset there?
Yeah, so I think what is it? The team that has just started using it, we're not using a notebook-based workflow. They were using more of like the proprietary, like sort of like tools to kick things off. And so for them, they're really excited to use Flyte for all the reasons that we've discussed, because they're engineers writing pipelines. I think our next step is working more with the data scientists who use notebooks and setting that up. But we haven't quite gotten there yet. But I will report back with feedback. Yeah.
Awesome.